Hey folks, Maze Gosling here again for a video on energy. In this video, I am going to be talking about how to calculate potential energy, kinetic energy, and total energy. And to do that, I am going to look at 4 different scenarios with a 500 kilogram car. So what I'm going to do is I'm going to look at how much energy the car has at rest on the ground, moving at 15 meters per second on the ground, at rest 20 meters off the ground, and finally moving at 15 meters per second, 20 meters off the ground, because guess what? It's a flying car. And for this video and for this problem, what you're going to need to know that potential energy is equal to mass times our gravitational acceleration times the height of the object off the ground. You also need to know that kinetic energy is equal to half of the mass of the object times its velocity squared. So without further ado, let's go ahead and get started with part A. So for part A, our car, which I'm going to go ahead and draw, is at rest and on the ground. So V equals 0. I'm going to go ahead and label this as my givens, guys. So V is equal to 0. M is equal to 500 kilograms. H is equal to 0 meters. And G is, as always, 9.8 meters per second squared. And I'm actually going to go, for the sake of this video, I'm going to go ahead and round G to 10 meters per second squared. Just because it makes the math a lot easier to do. Okay, so my unknown here is total energy, which I'm going to call E, and that's going to be equal to PE plus KE. So I'm going to call this my unknown and equation section, because I've kind of combined the two. So let's go ahead and put in our equations. So let's do our expanded equation. Our energy is equal to our potential energy, which is M times G times H, plus our kinetic energy, which is 1/2 of mv squared. So putting in my numbers, I have that my energy is equal to 500 kilograms times 10 meters per second squared times 0 plus 1/2 times 500 times 0 squared. Or my energy is equal to 0 joules. And this is kind of what you would expect to see, right? I mean, our car isn't moving and it's not off the ground, so why would it have any energy? So if an object is at rest and sitting on the ground, its total energy is 0, its potential energy is 0, and its kinetic energy is 0. Now we're going to move forward to part B, in which our car is moving and is going at 15 meters per second. It is still, however, on the ground. So let's go ahead and draw that out. So here's our car on the ground, and it is going at 15 meters per second. So let's go ahead and write out our givens. So given, our mass is still 500, little g is still going to be 10, h will still be 0, but now v is 15 meters per second. Now, our object is on the ground, so that means that we know that our potential energy is 0 joules. If you don't believe me, you can go ahead and you can calculate that out, but remember mgh is going to be multiplied by our height here, which is 0, which is going to, of course, give us an answer of 0. Again, if you don't believe me, try it out for yourself. So now let's go through our unknown, and our unknown here is, again, our total energy. And now we can go ahead and add in an equation. So our equation here is that our total energy is just equal to the kinetic energy because, again, our object has no potential energy. So expanding that out, we have E equals 1/2 mv squared. And so now we have isolated our variable. We've expanded out our equation into our so that it just has our givens and unknown. And we can go ahead and substitute in what we do know. So let's go ahead and do that. I have E equals 1/2 times 500 times V, which is 15, squared. And I am now ready to stick that in my calculator and solve. And when I do that, I get that my energy is 5,600 joules, or I could also write 5.6 kilojoules. And there we have it. We have now solved for the total energy of an object that only has kinetic energy. So we're going to go on to part C. And in part C, our car is now at rest again, but it is 20 meters off the ground. So our object this time is going to have potential energy because it's off the ground, but no kinetic energy because it is at rest. So let's go ahead and list out my givens. I know, again, mass is 500, G is 10, and I'm going to go ahead and add in my units as well, so kilograms and meters per second squared. I also know that the height of my object is 20 meters, and again, kinetic energy is 0 because my speed is 0 meters per second. So I'm ready to go on to my unknown. And my unknown here is the same that it has been for all of the problems, and that is my total energy. And again, my equation is going to be essentially the same as my other problems, where my total energy is equal to my kinetic energy plus my potential energy. My kinetic energy is 0, so my energy is just equal to my potential energy, which is m times g times h. And I am now ready to substitute and solve. So let's go ahead and do that. So my substitution step, I have E is equal to 500 times 10 times 20, so m times g times h. And when I stick that in a calculator, or for this problem, you probably can do it in your head, I get that my energy is equal to 100,000 joules, or 100 kilojoules. And now I am ready for my very last problem. And in order to get enough space for that problem, I'm going to go ahead and I'm going to erase set part A, because there's not really all that much to do there. We've already gone over it, and you guys don't need it anymore. So let's go ahead and finish part D, finish our problem. So now our car is moving at 15 meters per second, and it is 20 meters off the ground. So now my car has both potential energy and kinetic energy. And so my givens, I'm going to go ahead and list out everything that I know. So first of all, I know that the mass of my car is 500 kilograms. I also know that little g is 10 meters per second squared. I know that my car is 20 meters off the ground, and that it has a speed of 15 meters per second. And I am ready now to go on and list out my unknown. And in this situation, again, my unknown is my total energy. But my equation is going to look a little bit different because, again, I have both kinetic and potential energy. So my equation is E equals kinetic energy plus potential energy. And instead of getting to cross off one of these, I have to keep them both. So my kinetic energy is 1/2 mv squared, and my potential energy is mgh. Now I have my equation written, and I have isolated my unknown. So I'm ready to substitute and solve. So let's go ahead and put in some numbers. So my energy is equal to 1/2 times m, which is 500, times v squared, so times 15 squared, plus m again, so 500, times 9.8, times times my height, which is 20. And I can go ahead and solve. So I know from parts B and C that my kinetic energy is 5,600 joules and my potential energy is 100,000 joules. So I can just go ahead and add those together, and I get that my energy is 105,600 joules, or 105.6 kilojoules. And there you have it, folks. I have gone and I have solved for my total energy of my car in 4 different situations. One where it had no energy, a second situation where it only had kinetic energy, a third situation where it only had potential energy, and finally, my last situation where it had both kinetic and potential energy. So now, you can solve any energy problem that you are given. Just make sure you draw a picture and that you are aware of what kind of energy you are trying to find.